If you can hear me, feel free to ask me a question. If you can hear me, just feel free to ask me a question if anything goes. If you have a physics question, feel free to ask me. You can just type it in the chat. Everybody, if you have a physics question, feel free to ask. You can type it in the chat. Everybody, if you have a question, drop it in the chat. Do my best to answer your question. High school physics, university physics, introductory physics, any questions you might have, or if you're getting ready for classes this fall, if you have questions about getting ready for class, that works too. Cool. Farine, can you explain Newton's third law and give a day-to-day example? Yeah, so Newton's third law, when you first hear of it, I think it sounds somewhat simple, or every action has an equal and opposite reaction. But it's deceptively kind of, there's more to it. I think there's more detail to it. So the kind of the everyday example you can think of is when you're sitting on a chair, kind of a pretty simple, I'm sitting on a chair. So when you think about the forces that are in balance, right? So I'll let you take a shot. So if you're sitting on your chair, couch, wherever you're sitting, what are the forces you think are acting on you? Or just in just general, just what are some ideas? We can talk about it. And so or anybody else too, you can jump in. And yeah, so sitting on the chair, yeah, weight. So when we mean by the weight, we are talking about the force that the earth is pulling down on you, right? So the earth is pulling you down. That's what we consider a weight, that force. Normal force, yeah, so it has a funny name, normal as in perpendicular, 90 degrees. So if you look on the dictionary, I don't know, something like the fifth definition of the word normal is perpendicular or 90 degrees. So yeah, so the surface itself is pushing, right? So the chair or the couch is pushing up. What else can you think about forces wise? So the earth is pulling you down. The surface, let's say the couch or the chair, is pushing up. Anything else maybe that you can think of? Those are good. Those are maybe, maybe not. uh, I'll give you a second. Think about other forces. As you're sitting on a chair, there is a force that the earth is pulling you down, which we call weight. There is a force that the chair is pushing up on you, which you can call the normal force. What else can you think of? Yeah, friction, possibly. In this case, you can probably ignore friction. Friction's oftentimes there. It just depends on if it's a big deal or not, right? So yeah. So in the context of you sitting, the friction is probably not that important. So what I was thinking about is when you're sitting on the chair, you clearly feel that the chair is pushing up, right? Like on your bottom, you can kind of feel that the chair is pushing up. But there's also you, right? You're actually pushing down on the chair itself, right? So you're pushing down. And the other force there that it might not be obvious is the fact that there's a force that the earth is pulling you down, right, which we call weight. But the reverse is also true. You are pulling up on the earth. Now, this sounds kind of funny because the earth is very big and it's very massive, so it doesn't really get affected so much that you are pulling on the earth. But in both cases, like if the earth is pulling on you, then you are pulling on the earth by an equal amount. Okay, so there are four really forces in that case that you can think of if you're sitting down, right? So earth pulling down, you pulling up on the earth, the chair pushing up, and then you pushing down on the chair, right? So simple example, but you can see that even the simplest cases, you have to really be careful and think about it in detail, right? So Newton's third law, to your question, every force, right, every action has a equal and opposite reaction. The little bit that's not in the kind of everyday version of things, of when you say Newton's third law, most people will say every action has an equal and opposite reaction, right? So the comma and the additional part of that is that the forces are acted on by two different objects. Okay, so there's a bit of a noise outside, but hopefully it's not too bad. I'll give it a second. So the two forces, right, the equal and opposite forces, should come from two different objects. So when you're trying to identify the action-reaction pair, if you realize that both those forces are done by or on to the same object, then that's not the action-reaction pair. And that's the hard part of Newton's third law, is understanding what is the actual action-reaction pair, right? So in the case of weight, right? So I'll let you think about it. In the case of weight, which is the earth pulling down on you, what do you think is its reaction, right? If the action is the weight, right, the earth pulling down on you, what do you think is the reaction to that? And anybody can jump in, so feel free to put it in the comment. So if you just joined, the question is, if you're sitting on a chair we're trying to identify the action-reaction pairs in Newton's third law. And the action force that we're going to focus on right now is weight, which is the earth pulling down on you, right? That's what we call weight. And what we're trying to do is identify the reaction to that. What is the actual reaction pair? And I think Janil, I think you have a question too. I'll get to yours in a second, but any guesses? What's the reaction to weight? And the hint of the thing you want to always keep in mind when you're applying Newton's third law is the two forces, action reaction pair, should not act on the same object, right? And in certain cases, there's multiple forces, right? So that's fine. But one of the common points of confusion is that students will pick two forces that seem like they're the action reaction pair, but they're not actually the action reaction pair. So in the case of weight, what do you think is the reaction to that? See gravity. So yeah, so gravity is you're on the right. Yeah, I think you're probably thinking about it correctly. So weight is gravity, right? So it's just kind of what kind of force we're talking about. When we say weight, we're saying the Earth pulls on you, right? That's what we consider the weight, right? That force. Now, the reaction to it is you pulling back on the earth, right? And that's also gravity, right? So the reason why that works is because you have mass and the earth has mass, and so you're able to tug on the earth. So that's the action reaction pair. Now, notice that the weight, right, the force of the earth is pulling on you, right? You're the object being acted on. And when you pull on the earth, then the object that's acted on is the earth, right? So the action reaction pair should be on two different objects, not the same, right? Now, in this example, the two forces that seem like they're opposite each other, action reaction that are not, is the normal force, right? That's act. So the chair pushing up on you, and what? Right. So if you look at the chair pushing up on you, that's the normal force. And if you say the gravity of the earth pulling down on you, notice that those, yes, seemingly are opposite, but they're not the action reaction pair in Newton's third law, because both of those forces are acting on you, the person, right? So the chair pushes on you, the earth pulls on you, everything's acting on you. And so that's not the action reaction pair that Newton's third law is about, right? So everything in physics is very specific, right? So it's not that other things are not true. It's just that when you're saying, I am applying Newton's third law, it means something very specific, right? That there is a certain action-reaction pair that acts on two different objects. Is that clear in terms of your question? Before we move on, I want to make sure that I answered your question about Newton's third law. And here's an everyday example, right? That pretty familiar if you're sitting on a chair, right? Yeah, it's yeah, good. Hopefully it makes it clear. It's yeah, of Newton's laws, Newton's third law is often kind of talked about as, oh yeah, yeah, by the way, here's this additional thing, but it's a really important one, and I think it's easy to make some mistakes there because yeah, sometimes it seems too obvious, right? So that like, yes, every action has an equal in it, so then people move on too quickly without thinking about, hey, what does that really mean, and in a particular context. So in the case of sitting on a chair, you have four different forces, but you have to be really careful which one's paired with which, right? According to Newton's third law. And is Janil still there? I'm gonna just double check if you're there. And the question was explain quantum physics. Tough topic. Maybe you can explain a little bit more what you mean. I do want to stick to kind of high school introductory physics going through the first year of university physics. So algebra based, calculus based, that's okay. I want to kind of focus on mechanics, which is like Newton's laws, as Farine just asked, and work energy, thermodynamics, right? So things like that are going to be in your first semester of physics. In the second semester of physics, you can talk about light, optics, lenses, mirrors. You're going to talk about charges, right? Electricity, circuits, then magnets and magnetic fields, and how all of that combines to produce light waves. And so that's going to be kind of intro physics for the first year. You typically don't cover quantum mechanics in your first year. It's a tough topic, but if you have something kind of general, maybe I can sort of direct you in a certain way. But it is a hard topic for sure. So maybe you can clarify your question. And if anybody else has a question, please feel free to type it in. Happy to take questions. Okay. Yeah. So we wait for Janelle to answer if there's something specific about quantum physics they want to know. Farine. Yeah. So you're mechanical engineering. Mechanical engineering, but you don't require physics too. Okay, that's curious. Typically, engineering majors. So I did engineering too as an undergrad. So engineering majors across the board typically require both physics one and two. So it could be your program. Everyone's different, right? So the other thing also to watch out for is some engineering programs prefer to do certain topics on their own. For instance, Physics 2 talks about electricity and particularly circuits when it comes to engineering. So some engineering majors will have a separate class, either mechanical engineering, electrical engineering, a separate class that talks about circuits because they want to go in a certain level of detail. So that could be your case. I always encourage taking the entire series, Phase 1 and 2, but within reason, of course, follow your degree program, talk to your academic advisor, of course. If you have the time, right, take Physics 2. It's nice. It's a nice series to have intro physics covered, algebra-based, calculus-based. Maybe you're taking calculus-based. I think that's a really solid foundation for everybody, particularly if you're going in engineering, you're going in some physical sciences. But in my opinion, everybody, if I can get everybody to take intro physics the first year, I would, because I would argue it's really useful for everyday life. A lot of things in everyday life and nature, right? So sitting on a chair, your phone, plugging your phone to charge, all these things are physics, right? So having some rough understanding of how that stuff works is just makes you a more complete person, helps you in your career, right? So I would always encourage more physics than less physics, but that's just me. Okay. Okay. Sorry to hear about the experience. Yeah, it happens. So sometimes the class doesn't go well. Self-study wise, I would say OpenStax. Let me try to find the link here and I'll put it in the chat. OpenStax is a good website. They have lots of textbooks for free. They're peer reviewed, so it's not like somebody just wrote up a physics book. Um, so their books are pretty good. So let me put this in the chat. Yeah, so OpenStax, yeah, lots of subjects, including physics. Just FYI, when people say college physics, they mean algebra-based college physics. When they say university physics, they mean calculus, right? So that's just an odd phrasing for. So if you ever see textbooks that are saying college physics, most likely they mean it's based on algebra. If you see university physics, it's calculus based. You have other topics in there as well, chemistry, so on. If you want to look up some math textbooks in there, that's pretty good. So if you want to self-study, that's a good place to start. I'm sure you know about Khan Academy. I'll drop it in the chat as well, just so everybody has a link to it. Khan Academy is pretty good too. Yeah, one's a book, one's a textbook, of course. I always encourage more reading. Don't skip the reading. A lot of students find that they don't want to read, or particularly they don't want to read technical information. But I think it's good for your development, good for your understanding when you read technical information, right? Particularly from a textbook. So I think that's really good. But you can also watch videos, right? So that's also an additional thing. And Khan Academy also has, I think, modules and things you can work on, so you can try out your knowledge there. So I think two I would highly recommend is that. Um, yeah, for self-study purposes, particularly if you're taking physics 2, I would really encourage you to go review your physics 1, particularly vectors, because vectors shows up a little bit in physics 1, but vectors are all over the place in physics 2, right? So it's like from, yeah, for the vast majority of physics 2, you're going to deal with vectors. So I think particularly that topic is something you want to brush up on. But other things will show up, energy, right? So things like that that's was in physics 1 will show up in physics 2 as well. So yeah, always good to have a good foundation with physics, I suppose with math as well. You don't want to move to the next topic till you're pretty solid on the previous topics, because if you say, don't worry about it, I'll figure it out later, it doesn't quite work that way. So there are other subjects maybe where you can kind of skip ahead to a later point and then pick it up there. Physics is not one of them. So definitely make sure your foundation is pretty good. Yeah, happy to take any other questions. A couple of people on the stream here, so anything goes. If you have any physics related questions, getting ready for physics class, any uh, math kind of things that might be tripping you up as well. A lot of times in physics, it's actually the math that gets students stuck. Yeah, happy to help. I'm trying to figure this out. So I'm going to be tutoring online. I can put my website as well. So if you want to check it out. So I taught at the university level for 4 years at the University of Texas. So I have a lot of experience teaching physics. So now I'm trying to do this online and slowly move things so that it's virtual. And yeah, so definitely I'm doing individual tutoring, and from time to time I'd like to hold these office hours, kind of like no charge, just just kind of drop in, and you can ask questions. I wanted to start a little early in the kind of academic year because the fall semester hasn't started yet, just to try this out, just to see if anybody joins and asks questions. And so looks like it'll be useful. So then I might do more of it. So yeah, I'll try to figure out a good schedule and post it on the various places. So I'm on LinkedIn, I'm on social media, Instagram, TikTok, all this stuff. So yeah, particularly if you subscribe to YouTube, anytime I have a live session, I think you should be notified. You can hit the bell or whatever it is, and it should notify you. So when I'm doing it, so at least once a week, I'm hoping to do it a little bit more, and then as the semester gets going, I might do it every day, right? Particularly if I can be helpful. So. Feel free to ask me any questions. Be here for a few more minutes. Everybody, yeah, if you have questions about high school physics or the first year introductory physics, either algebra-based, calculus-based, if you're taking the class, maybe you're taking a summer class, or if you're going to be taking a class, physics class in the fall, any questions you have about that, happy to answer. You can just type it in the chat. Yeah, so you have a question about fluid mechanics. Why does the pressure increase with depth, even if the container is narrow or wide? Yeah, so I'm happy to, it's not something I think makes a whole lot of sense if you try to think about it. So it's one of those questions that really requires you to work it out on paper. So let me switch over. I have a iPad connected here, so what I can do is write. Hopefully you can see it. Let me do this. Okay. Okay, this should appear. Okay, can you quickly let me know if you can see me kind of writing? So just if I do that, can you see that on your screen? Just want to double check. I'm setting all these things up for the first time. Cool. Yeah. So then I don't want to. Okay. So what I want to do is think about a container. Okay. And let's say you fill it with water, right? So let's say you fill it with water. And what we want to do is try to figure out, okay, how does the pressure change, right? So we could have an atmospheric pressure, right? So it's the same pressure. The pressure as a function of depth works with the atmosphere as well. But let's just say that we'll take that as a given, right? So we're not going to consider the atmosphere for now. Let's say that what I'm going to do is say there's a pressure from the outside, right? So if you watch the weather or something, right, there's some pressure reported every day, right? So that's at the top, and we want to figure out, okay, at the very bottom of this container right here, what is the pressure, right? So at the bottom, and I'll say that's the total pressure at the bottom of the container, right? So if we can kind of guess that it should be higher than the atmospheric pressure right here, right? So this pressure right here is some number, but we can kind of guess that as you go down in the container, right, that the water is going to add. And so you have firsthand experience of this, right? If you in the ocean, you get in the swimming pool, right? The further you go down, you feel more of a pressure, right? Okay, so what we'll do is try to figure out what this is, right? So how does this actually vary with depth? So this is the bottom of the container. And what I want to do is think about, okay, so pressure, right? With the when we say pressure, what do we mean? So pressure is some force over some area, right? And for a moment, let's ignore the atmospheric pressure. And what I want to do is just consider what the water is doing, right? So the force, right, that's acting on the bottom of the container is the weight of the water, right? So if you just imagine you're really tiny, you go down at the bottom of the container, what's pushing you down is the weight of the water is pushing you down, right? So that's the force that's acting over what area? Well, this area, right? So there's this area of the container at the very bottom, and that is the area that we're dividing by, right? So this force here, right? This force that we're saying force over area is really the weight of the water divided by that area, right? How are we doing so far? Kind of following along? Ask me questions while I go. So if something's not clear, and that's for everybody. So as I do this. Yeah, so you're following along. So you have the weight over the area. So then let's just think about what do we mean by weight? Okay, well, the weight is the mass, right, of the water times this g, right? So if you've seen this before, then this might make sense. But if you've not seen the idea of a weight, it comes from F equals ma, essentially. So mass, like this is the ma. The a is the acceleration due to gravity in this case. So when we say weight, we mean the mass of the water times g, right? 9.8 meters per second squared on the surface of the earth, right? Again, divided by a, right? The area. So we just keep breaking this down, right? So when we say mass, what do we mean by mass? Well, by mass, I mean, well, what if I take the density of the water and then multiply by some volume, right? So when I say mass, what I mean is the density times volume, right? Density is mass per unit volume. So if you multiply volume, you'll get the mass, right? So then that multiplied by g divided by a, right? And now we're going to break down this volume, right? So when we look at this water, what do we mean by the volume of the water? Well, there's some height to this water, right? So the volume of this water is, if you just take that area and multiply by the height, that's your volume, right? So that usually works with volume. If you just have a cross-sectional area and multiply by some distance, height, then you get volume. So what we're going to do is rewrite this, right? So we can say density, and instead of volume, we're going to say times the area times h, right? and then divide, so don't forget G, divide by A, right? And so notice what happens here, right, is that the areas will cross out, and what you're left with, right, is equal to rho times G times H, or rho G, rho H and G, right? So oftentimes this is just, I remember it as rho GH, right? It doesn't matter which way you multiply, it's the same thing, but I just remember it as rho GH, right? So that's just the pressure at the bottom of the container due to the water. And remember, we have the atmospheric pressure at the top. So when we want to write total pressure, we write the pressure from the atmosphere plus this contribution due to the water, right? So rho GH. So if you want the total pressure, that's how you get it, right? You get total pressure by taking the atmospheric pressure and you add the contribution from the water, right? So rho times G times H. Now, to your question, notice that it's a long story to your initial question. This is why it's only a function of height, right? Because there are certain parameters that do depend on the area, the wider the container. But notice that the wider the container, you have more force, more weight, more mass, right? More volume, right? So all those things come into play. But you're also dividing, right? Because ultimately the pressure is dictated by an area. So the wider your container, you're making the area bigger. So those two factors cancel, right? So literally in the math, that's why this the A's here, if I highlight this, right? So these areas drop out because they are coming from different things, right? So the area is a part of the weight argument, right? So up here, this weight had an area in it, right? That's what we're showing. And then of course area has an area in it, right? So that's why the areas cancel. So yeah, so if you look at the pressure in a fluid, it only depends on the height, and that's why, right? So that's the explanation of why that's happening. Does that answer your question, Farine? Hopefully. Yep, good. Anybody else have questions? I'm gonna end the stream in a little bit here. I'll try to do this more often. Sounds like it'll be helpful to a bunch of people. So I'll put out some information on social media, on YouTube, right? So if you go to my website, it's on the chat here, virangaperera.com. You can find my information, how to contact me, all the social media stuff. I'm on LinkedIn, I'm on Instagram, whatever you're on, I'm probably on it. If I'm not on something, let me know and I'll look into it. But yeah, this will stay on YouTube. I'll produce the video of this and that'll live in YouTube. And then like I said, I'll do more of these, particularly as it gets closer to the start of the semester, school starts up. Then I'll try to do more because as you have your classes going, and probably have more questions. So I'm happy to help. So anything else that I can help with before I jump off? All right. Well then, thanks for coming. I'll try to do more of these, and so good questions. Take care. Talk to you soon.